Another very common programming assessment question is the reversing of the linked list. So you have some linked list, and if you're familiar with the data structure of a linked list, the idea is you have some node that goes to another node, and that one goes to another one, and so on. And what you want to do is flip it, right? So in example 1, we have 1, 2, 3, 4, 5, and then we want it to be 5, 4, 3, 2, 1. Now, if you haven't seen a problem like this before, you haven't worked with linked lists before, this can appear very confusing, and rightfully so. Okay, and I'm going to do my best to boil it down to fundamental code that really makes it feel intuitive, feel normal, feel natural. And first I want to deal with any edge cases. So first, let's say if not head or not head.next, return head. This means that it's an empty linked list, or there's a singular node that's not connected to any other node in a list. Okay, so after that, the way we want to look at this is you're going to need 3 pointers, 3 things that point at nodes, and we're going to slide them across. So we'll slide them across one at a time, and what we'll do is we'll break the connection between the first and the second one, or rather the second and the third one, and then we will connect the second to the first node, and then we'll slide them over. So then P1, or the first pointer, becomes the second pointer becomes the third, and the third becomes the next node of itself. Okay, and then we'll repeat that process until we've reversed the linked list. Okay, so let's start by making our pointers. So P1, P2, P3 equals none, head, and head.next. Head.next. Okay, so at first, our first pointer is pointing at nothing, and you'll see why that's very convenient shortly. Now let's handle an edge case using this technique. So if not p3 dot next, in other words, now we only have 2 nodes that we're dealing with pointer 1 and pointer 2. If not p3 dot next, then p2 dot next, we break that connection, equals none, right? And then p3 dot next equals P2, return P3. Okay, so we've broken that connection, we connect P3 to P2, and P1 is none, so it's not included, and we just return P3. That's when we have 2 nodes. Now in the event that we have more than 2 nodes, what we'll want to do is that sliding window technique that we just talked about, where we break a connection, connect it to the previous one, and slide them all over by 1. So let's just say while true, P2.next equals none, we break the connection, P2.next equals P1, and then we say if not P3, that means we've reached the end of the list. So in example 1, you'll see P3 originally starts at node 2. When we slide across and we let our while true loop run until P3 gets to the end, it'll get to just outside of 5, which will be none. So if not P3, that means none. Return P2, because P2 at that point will be at node 5, and that will be connected to the previous node, which is connected to the rest, and so on. Then of course, in the event that that's not true, which is if not P3 is not true, P1, P2, P3 equals P2, P3, and P3 dot next. This is that sliding over by 1 that we just talked about. We run, accepted, submit, outstanding.